Right. So I'm here to talk to you about a kind of complicated topic, which is high economic security replicated deterministic general purpose computing. And if that's a mouthful, basically, if you want to either run PHP or help run PHP with a $5 billion economic security budget, this is how you can potentially do it. And let's quickly jump into what this Cartesi machine is. So the Cartesi machine is an open source RISC-V emulator. It's fully deterministic, as in if it starts out in a particular state, it ends up in the same state all the time. And it implements what's called the RV64 ISA, which basically means, for the people who don't know this about this kind of technology, is it can basically run Ubuntu completely unmodified, right? It can have 64 bits of memory, which means that you can put basically any kind of computation you reasonably want to put inside it. It's something that's not new. It's not like some new fancy VM that we're developing. It's something we've been doing since 2018. And what's interesting, because it's deterministic, is that it's completely, all the state of the machine is in memory. It can be mergalized at 60-bit word level, and you can persist the state. You can kind of like optimistically prove it, like let's say some of the optimistic rollups are doing. It's programmable, and I personally think that for, let's say, coprocessor kind of like services on eigenlayer, like a general purpose processor that can essentially run a full 64-bit operating system, is basically the perfect thing for it. So we are kind of like a prototype stage at the moment, but like kind of like what we are doing with eigenlayer and Cartesi is that we have basically a Tendermint-based network where they claim that they have a particular easy DSA key in eigenlayer. They claim a certain weight, which basically means we set up a small proof-of-stake network. We then kind of like get a consensus of the Tendermint network and have the operator list come from eigenlayer confirming it. And then we have one simple kind of like transaction type, which is kind of like run a certain input to compute using a particular piece of machine, which is like can be a complete Linux machine. You can run JavaScript, you can run TypeScript inside it, WASM, whatever you kind of want, ZK verifiers, right? And then what happens is that each of these validators are then running the input in our so-called Cartesi machine, the virtual machine, and storing the output in a Tendermint state. Then we have kind of like a sidecar server, which basically we can use to kind of collect the ESPN 256 signatures of that computation state, and then basically take that, all those responses, and put it in on Ethereum. So it's a nice little kind of like coprocessor that you basically can start prototyping something up in JavaScript, and then basically start putting in quite easily onto something like Ethereum. One of the things that is a benefit, because we can do this in an optimistic manner, is that let's say that somebody is claiming a faulty computation result and signing it with their keys here, we can actually go in and optimistically slash them. And we can also do, let's say, metered execution, because basically we can do execution step calculations inside RISC-V, because it's basically cycles of a virtual CPU in this particular case. And let's see if the demo works. It's a little, yeah, okay. So basically what we have here is the playground, and this is not that big. Is it possible to get it bigger? Like just make it bigger? Okay, anyway. So we have basically our Cartesi machine over here, and under here we have kind of like a small little application here that's interfacing with the Cartesi machine. And then what we're doing here is that we are initializing a new Tendermint node here, booting our example application. Now we're running a blockchain essentially with particular validators. Now next up, what we want to do is then to actually go in and take an operator that comes from eigenlayer and put it into our proof-of-stake system. So we go in and we basically sign with that we're kind of dragging in this particular operator with this particular weight. And we can see down here, it's, don't know if you was able to see it down here, but it was like basically said that it added the validator. And now what we're doing here is compute, and you can see up here, basically in less than a second, basically a Python script with the input, Python 3 script with the input was then is running inside the machine, yielding a particular output, and now we go in and kind of like collect the signature from the consensus of the validator network and getting the computation out again. You kind of can't see this, but you know, you'll have to trust me on this one. And yeah, that's basically it. Okay, so going further. So where we think that something like Cartesi and eigenlayer is kind of useful together in the kind of co-processor sense is that smaller, kind of like more stateless computation. Let's say we add signatures or verifications or things that need very high level of security, like let's say order book or DEX or something like that. Things that are not kind of trivial to write in ZK proofs on Solidity. For example, let's say doing something as simple as going in and doing a BLS 381 verification. Stuff that's more like, let's say, temporal, like order books. And basically, the thing here is you can compute anything that compiles to RISC-V instruction set, which is an open instruction set that is supported by many different compilers, tools, etc. So basically, it feels like basically uploading something to the cloud, but instead it's actually being replicated across many eigenlayer using validators in this particular case. Or you can do PHP on this thing if you're so inclined. And if you want to know more about Cartesi, we have Cartesi.io, more about the Cartesi machine, which is really a quite curious piece of technology if you have been seeing the AVM. It's much more like, let's say, a normal computer. You can read about the documentation here. If you want to contact me, you can, of course, come and talk to anybody who has a Cartesi t-shirt on. Or you can poke me on X or Twitter or whatever you call them these days. Talking on Discord, and just want to say thank you to my team members for doing the demo development for this one. Yeah, that's pretty much it.